first example. Give me any function, please. Make up any function you want. Any function, please. You have tons of functions. Trey, will you give us a function, any function you can think of?
X squared plus 8x.
You said 2x, okay, plus natural log x. So here we can be asked two things. To find f prime of x, which is 2x plus 2 plus 1 over x. But I can be asked to find dy, which is by definition f prime of x dx, which does not equal f prime. Dy equals 2x plus 2 plus 1 over x times dx. I want to make sure that you understand the difference between this and this. This is the derivative function. This is the differential of f of x. Derivative function of f of x. When I'm asked to find the differential, I'm asked to find dy, and it has to be f prime times dx. When I'm asked to find the derivative function, this is it. And now let's play with this concept of differentials. Okay, let me start with a simple example. We are in 310. If you want to pick, I would like to start with, I illustrated the differential. I don't think we need another one like that. But let's say we have y equals cosine pi x. We are given x equals 1/3. We are given dx equals negative 0.02. And we're asked to find part A, dy. And in part B, they want us to evaluate dy for the given information. Can anyone help with dy, please? Anyone? Kaylan, will you tell us how to write dy?
Is it going to be something like negative sine?
Negative. Oh, yeah.
Yeah, and then the chain rule. So,
Is it negative pi? Times pi?
Times pi.
It's going to be pi
Times.
dx.
Thank you very much. This is it. Yes, I should put pi in front. That's okay. So then dy, I have negative pi. I have sine pi x, pi divided by 3. And multiply by dx, which is negative 0.02. Make sure that you have your calculator in radians, radian mode. Let me share my screen again. So make sure in the mode, you always have radians. Be very careful. Okay, it's highlighted. So now I can calculate. There are two negatives. I'm not going to put a negative. It's positive. So pi multiplied by sine pi over 3. I know the answer is the square root of 3 over 2, but I need an approximation, so it's the same thing if I just put it in. Sine pi divided by 3, and then multiplied by 0.02. And the answer is that. So this is the approximate error, 0.0544. I would choose 4 or use 4 decimal digits. Okay. I would like to go back to our formula. So what did we say the relationship was between delta y and dy? One more time. What is the connection between these two?
Approximate.
Very good. Now this time I would like us to write what they mean. Can anyone tell us what this means?
Change in y.
Right. What is the formula?
Y. Or that's just going to be like the y plus a little bit minus y.
F of x plus dx minus f of x, approximately. What is this? We just used it.
F prime of x dx.
Very good. Awesome. And I'm going to move f of x to the other side of the squiggle symbol, the approximation symbol. F of x plus dx, approximately f of x plus f prime of x dx. This is super important, very important to remember. Okay. So I would like us to approximate the square root of 99.8. And no, I'm not asking you to plug it in the calculator. Everyone can do that. So I'm asking us to identify every little piece here and approximate it with whatever. So first I would like us to start by identifying the function. So looking at this, we should be able to identify a function used here. What is the function used here?
Square root.
Very good. Now let's identify x and then the little x, dx. So what do you think x is here and how much is dx?
So the x is going to be 99.8, right?
We have an x and we have a tiny error.
Would be 100.2.
Very good. But I cannot write 0.2, but I have to write
Negative.
very good. Okay, so we identified x. We identified the tiny error. Now we have the function that we will evaluate at 100. We have dx, no problem. But I also need f prime. So let's find f prime of x. What will that equal to?
1 over 2 x.
Excellent. And now I have to put everything together. F of x with x in it is f of 100 plus f prime of 100 and multiplied by dx, which is negative 0.2. This is true. This is the equal symbol. This is not the equal symbol. But all this equals, because I wrote in between, I'm going to circle it so you know where it's continuing. It's continuing here. Can anyone give us f of 100?
10.
Very good. 10 it is. Plus. Can anyone give us f prime of 100?
20.
1 over
20.
Good. And multiplied by negative 0.2. So this is 10 minus 2 over 200. I don't like decimal numbers in a fraction, so I multiply top and bottom by 10 without changing anything. So this is 10 minus 1 over 100. 1,000 minus 1 999 over 100. This is guaranteed. You have never even dreamed of knowing that this is very close to the square root of 99.8. Let me share my screen. So here it is. 999 divided by 100. I don't have to do that. It's 9.99. And the other one is the square root of 99.8. Very good. So now let's also look at something even more intriguing, like tangent 44 degrees.
I have a question.
Yeah, any question, please.
How did we find x and dx?
Because we are talking about a number and its error. We are talking about a number and a tiny error.
I got a question too.
Yes?
Instead of when we picked what we thought it was exact to, could we pick something else like maybe like 102 and then use a larger error offset?
Nope, because the delta x has to be small if you want a good approximation.
So choosing the smallest number possible is
Exactly. Yes. To have the best approximation possible. Yes. Absolutely. Good. So now here's one more that is even more intriguing. Of course, I write the definition, which I know it's very important to remember this, carved in stone, but I need to identify the function. Can anyone give us the function here?
Tangent x.
Can anyone give us x here?
44 degrees.
45.
Yes.
Oh yeah.
Because we know everything about 45, right? And also because dx is tiny.
-1.
-1 degree. Perfect. I also need f prime. That's how they were doing this before calculators. They didn't know how to calculate tangent 44. Good, so I need f prime.
Secant squared.
Good. And then I'm ready. Let's start. What do I have to write?
Tan of x.
Which is?
Plus
25 degrees.
Good. Plus?
secant squared of 44.
I cannot have x here 45 and x here 44.
45.
If x is 45, it has to be 45 everywhere, right?
Yeah.
And multiply by dx.
-1.
Tangent of 45 degrees is the same with tangent of pi over 4. It doesn't matter if in the calculator or anywhere I put degrees inside of a trig function or I put radians inside of a trig function. The answer will be the same. But if degrees are outside of a function, I cannot use it. I have to change this into radians. Inside of a function, it doesn't make any difference. But this is inside of a trig function, I meant to say. But this is outside of a trig function. Must be in radians. That's why I was saying make sure your calculators are in radians. So now I have to convert 1 degree into radians. Very easy to remember. On the unit circle, this point here is pi or 180 degrees. So the relationship pi equals 180 degrees. If I want 1 degree, I will divide both sides by
180.
Good. If I want 1 radian, I divide both sides by
Pi.
That's it. So it's -1, but it has to be multiplied by pi over 180. So times pi over 180. This is 1, this will be 2, but that will be the rest. Okay, I'm going to write this again because I cannot even put the equal symbol there and circle it or do something with it. So then tangent 44 degrees. You don't have to write it one more time, but I wrote so much in between. So it's 1 plus, remember secant is 1 over cosine. So 1 over cosine is 1 over the square root of 2, and then flipped is 2. So you'll see that that's 2. Multiplied by negative pi over 180, I will simplify to 90, and I have 90 minus pi over 90. No one is asking you to take this any further, but yes, I am kindly asking you to check your answers. So back to, I'm sharing my screen. Okay, so here it is. In parentheses, 90 minus pi, close the parenthesis, and divide by 90. And then tangent. Now I have to be very careful. I have to change my radians into degrees because I'm entering tangent 44, close the parenthesis, and it has to be very close, as expected.